Hey, what's up? My name is Andres from A3 Tutors, and today we're going to learn how to do fractions, how to add them, how to multiply them, how to divide them, and how to subtract them. Let's get into it. Okay, so let's start pretty basic. How do we multiply fractions? Well, the rule is pretty basic. Whenever we multiply fractions, we're going to multiply them directly, the top with the top and the bottom with the bottom. And all we have to remember is that for complex types of fractions, where we're multiplying just like a normal number with a fraction, that every normal number you can rewrite as that number over 1, making it a fraction. Then we're going to learn how to pretty much simplify them. So let's get into it with a couple of examples. Let's say we have 4 over 5 times 2 over 3. So this is going to be pretty simple. The top with the top and the bottom with the bottom. This is going to become 8 over, well, let's do this well. This is going to become 4 times 2 over 5 times 3, or 8 over 15. And that's pretty much it, because we can't simplify this. You'll see when you can. Let's do example number 2. Let's say 2 over 5 times 6 over 10. Well, just as before, we're going to multiply the top with the top and the bottom with the bottom. This is going to give us 12 over 15. Oh, I think I can simplify this one. Why? Well, because 12 is the same as 2 times, well, 4 times 3, right? And the bottom one, that's just the same as 5 times 3, right? And so because we're multiplying the same thing top and bottom, just as in this example, the general case, we're multiplying b in the top, b in the bottom, we're going to be able to cancel this out. And so let's cancel it out, leaving us with the final result, simplified final result, being 4 over 5. Boom. Let's do example number 3. Let's say we have 3 over 5 times 3 over 4. Pretty simple. This becomes 3 times 3, which is 9, over 5 times 4, which is 20. We can't simplify this further. This is our answer. Now, how do we do the sample case that we had before? Well, the sample case is pretty simple. We start off with 2 times 3, which is just 6, over 5 times 4, which is 20. 6, that's the same as 2 times 3. 20, that's the same as 2 times 10. And so we're going to simplify this, leaving us with 3 over 10. Next case, how do we divide fractions? Well, it's pretty simple once you learn this one rule. And so what's this rule? Well, it's the simple rule that whenever you multiply a fraction, or whenever you divide the fraction, it's going to be the same as dividing or multiplying the fraction as the opposite operation if we just flip the fraction. So for example, if I'm multiplying something, it's the same as dividing by that opposite fraction. If I'm multiplying by a over b, it's the same as dividing by b over a in any general case. So for example, right here, if I have 4 over 9 divided by 2 over 3, I don't know what that means, but let me turn it into something that I know. Well, how do I turn it into something that I know, like multiplication? Well, all I'm going to do is turn this division sign into a multiplication of the flipped fraction from 2 over 3 to 3 over 2. And now we know how to deal with this. 4 times 3, 9 times 2, 4 times 3, that's 12, 9 times 2, that's 18. And, well, we can simplify this further because this is the same as 4 times 3. This is the same as, well, 9 times 2, right? And 4 is the same as 2 times 2, right? And so we can simplify this like this. This is becoming, oh, and 9 is the same as 3 times 3, right? And so we can cancel these off, leaving us with 2 over 3 as the final answer. But notice all we did in here was flipping the fraction, turning it into a multiplication, and canceling off the terms as we did before whenever we turn whatever operation that we have into its multiplication. More famously, this is known as keep, change, flip. All right, let's apply this rule for this next one. Well, we know that 5 over 6 divided by 10 over 21 is the same as 5 over 6 times the flipped fraction, right? 21 over 10. And well, all we got to do now is multiply in front. This becomes, 105. This becomes 60. Well, if we break this down, this is the same as 5 times 21. And this is the same as, well, 6 times 10, as we did before. But we can't simplify anything yet. Well, we can if we turn this into 5 times 2. And so when we cancel these two off, we're left with 21 over 6 times 2, or 21 over 12. All right. For this next one, we do the same exact thing. 8 over 15 times 25 over 12. This becomes 8 times 25 over 15 times 12. This 12 we can break down into 4 times 3. This 15 we can break down into 5 times 3. This 8 we can break down into 4 times 2. We can even break them down further, but I don't want to because I want to cancel off this 4 off the go. And this 25 we can break down into 5 times 5. And so I'm going to cancel these off, and I'm going to be left with, yeah, that's pretty much it. 2 times 5, which is 10, over 3 times 3, which is 9. And this is the final answer. Cool. Now, how do we add fractions? Well, the way that we add fractions is by keeping something in mind. We can only add fractions in the case that the denominator is the exact same. So, if we have something like a over b plus c over b, notice the denominator is the same, we can add them into a plus c over b. Normal case, right here. If we have 3 over 8 plus 5 over 8, we can add them. If we don't have the same denominator, we cannot add them. But because this is the case, then we can turn this into 3 plus 5 over 8, which becomes 8 over 8, or when simplified, anything over anything is just 1. But notice this. This is going to be useful for the next problem. Now, what happens whenever we don't have the same denominator? Well, whenever we don't have the same denominator, we're going to have to switch it so that it does. We want to edit its form so that it does. What do I mean by edit its form? I'll get back to this in a second. Remember how we used this? We know that 8 over 8 is 1. Well, how about 4,000 over 4,000? Well, that's also 1, if you put it in the calculator. How about 1 million over 1 million? Well, that's just 1. How about 0.5 over 0.5? That's just 1. Well, how about pi over pi? That's 1 as well. Well, in fact, anything over anything is just 1. Well, how about this other fact? Let's say that we have 2,000 times 1. What's that? Well, that's just 2,000, right? How about 400 times 1? That's just 400. Well, how about pi times 1? How about 0.5 times 1? How about 300 over 300 times 1? Well, all of these will give you back that same number. In fact, anything times 1 gives you that same anything. But why is this useful? Why is this useful in the case of adding these fractions? Well, because we can combine them. And this is our way to turn any type of expression into a different form without changing the value of the expression. This is how we can change the form and not the value. This is what I mean. If we know that a times 1 is a, like anything times 1 is the same thing, and we also know that this is the same as 1, well, we could also say this. Right? And so, notice, we're multiplying by a fraction that, although when actually multiplied gives us this, the actual value of this, we know that it's going to be the same thing. So notice, this allows us to change the form of this a into ab times over b, right? But at the end of the day, we know that it's the same a, so we can treat it as the same a. we can change the form of this fraction without actually changing the value, the thing that it represents. It's the same thing but with a different form. And why is this useful? Well, because this is our way of forcing these denominators to be the exact same thing. This is what I mean. Well, because we know that if we multiply it by a fraction with the same numerator and denominator, we're going to get the same number. Well, we can multiply this fraction, for example, by 6 over 6. Why not? And I can multiply this fraction by 4 over 4. Why not? Well, notice, by me doing this, I'm forcing the denominator to be the same, because when I multiply the denominators, for each one, I'm going to have 6 over 4. 6 times 4 for each one. And so this is going to become 6 times 4, which is just 24, plus 4 over 6 times 4, which is also 24. Notice, now I forced this into being the same denominator, right? Now I can add these, as we said before, making this 10 over 24. Cool, right? Well, now we can simplify this. 10 over 24 is the same as 5 times 2 over 12 times 2. We can cancel this off, leaving us with 5 over 12 as our final answer. But notice, we use the fact that b over b times anything is that same anything, but with a different form. We're going to use this b over b as our weird 1 multiplication. Because at the end of the day, we're multiplying times 1, because we know that b over b is 1. So let's use that to solve this next problem. Well, for this one in particular, if I want to force these two to be the same, well, I can just realize that 4 times 3 is 12, right? And so I can multiply this one by 3 over 3. And this is going to become 5 over 12 plus 3 over 12. Notice 3 over 12 is the same as 1 over 4. It's just that this form of the 1 over 4 has the fact that the denominator is the same as the denominator on the left. And so now I can add these. This is going to become, all of a sudden, 8 over 12, because I can add these two together, given that the denominator is the same. And this is going to turn into 4 times 2 over 4 times 3. Right? I can cancel off these 4s. This is going to turn into 2 over 3. Cool. Now, last example for adding. Let's say that now we have these two denominators. They're kind of the same, they're kind of not. Now last example, let's say that we have these two fractions. They're kind of the same, they're kind of not. Their numerators are the same, but their denominators are not the same. That means we cannot add them, even if they are the same at the top. The denominator has to be the thing that's the same. And because it's not, then we can use the weird 1 multiplication to make them, force them into being the same. Into the same by just multiplying by the other one, such that by just brute force, this becomes 15 times 10, this becomes 15 times 10. And so now all of a sudden they're the same denominator. 15 times 7, that is 70 plus 35, 105. And 7 times 10, that's 70. 15 times 10, that's 150, right? And this now becomes 175 over 150. Simplify this at home. I'm really... you got this. Simplify in the comment section. All right. And now finally, how do we subtract? Well, I'm going to tell you it's the exact same thing as when you add or subtract. Well, now finally, the only exercise that we have left is how do we subtract? Well, it's pretty simple. It's going to be the same exact thing as when we added. Same exact thing. It's just that now we're subtracting. We want to make sure that the denominator is the exact same for both of these. If it's not the same, we can't subtract. If it's the same, then we can. And so we have to force it using these tools. That b over b times something, it's that same thing, that same a, but with a different form. We want to use these tools to change the form but not change the value. And so let's do that. Let's say we have this example, 11 over 12 minus 2 over 8. How would we do this? Well, we can brute force it into being the same denominator. I'm going to multiply this by 8 over 8, and I'm going to multiply this by 12 over 12. Pretty simple. This is going to become 88 over 8 times 12, which is, I believe, 96, minus 24 over 96. And so when we subtract these two, I'm going to get 64, I believe, over 96. You guys simplify this for me. Last example, let's say we have 7 over 9 minus 11 over 15. This is going to become the same denominator if I multiply these by brute forcing it. I'm going to multiply this by 15 over 15. I'm going to multiply this by 9 over 9. And notice now these two are the same because this is going to be 15 times 9 and 15 times 9 in the denominator for both of these. Well, 15 times 7, that's 105. 15 times 9, that is 135 minus 99 over 135. Now this is going to become 105 minus 99, which is 6 over 135. See if you can simplify this at home. If you can't, well, comment it. And yeah, that's pretty much it. I'll leave you guys the following exercises. This one, and this one. See if you can get it. If you can't, watch the video again, and hope you guys enjoyed it.